Alright, welcome back to the SciMax channel. Today I'm going to show you the integration of litdb and Jupyter Lab. So the previous videos have either used litdb at the command line in a terminal or in Emacs, and today I'm going to show you that we can use it in Jupyter Lab, and you can use a notebook interface you might be familiar with, and you'll have a file that you can save. So for the most part, we just import litdb. You can ignore this no QA. This is mostly for rough in the package for linting. Since we don't use this anymore, all this does is import some magics. We use it for the most part like this, %litdb. This is a line magic, and this just makes uses the same kind of CLI you're familiar with, or you might be familiar with, in a magic format. So we have all of these commands that are available in the command line interface. In fact, we used exactly the same code for that. And so we're going to start by just making a new database here. So this prompts me for an email address, and I'm not going to use an API key. And so this already over here you can see created the database, and somewhere there is the TOML file. Okay, and now I can use litdb about. It tells me where the file is located, and it's currently empty. So here I'm going to add my papers because I know them pretty well. So to do that, we need this org ID. So we just use the author search, and then here I'm going to just follow myself. And this takes a little while. It takes about 1 to 2 seconds per article, and there's 224 that have to be imported here. So we'll just have to wait a few minutes and see. You can see some files get created over here. These WAL and SHM files are just files that libsql creates in writing the SQLite file. So again, I use libsql here. It is a fork of SQLite, and the primary reason I use it is it has an integrated vector search that is not as trivial to get for SQLite. In SQLite, you have to add an extension, and there are a couple of extensions that are in the alpha plus stage of development, and I'd say none of them are like a clear front runner long-term solution. SQLite doesn't seem to have any interest in putting a vector search capability natively in, and so you have your choice of, do I build this extension? And there's some pretty good ones. You can read about it in this litdb documentation. Or do I try using libsql, which is has the additional benefit of one day you could put this database in the cloud if you felt like it. Right now everything's local. I don't do that, but it's a possible direction for the future. It's also nice that it's just fully integrated. You just pip install libsql and then get on with your business. One of the reasons this takes so long is because of that vector search. For each entry, we actually embed the title and abstract and get a vector that gets stored in the database. And that embedding is not super fast. It's a little bit tricky. You can get the embeddings in batches, which almost certainly would be faster. But I have not made it do that because there's other things that happen, and the code is simpler if you just do one entry at a time. Guess I have time. Why don't we look at how this is actually done? So the code to get the Jupyter magics is remarkably simple. we just import the CLI, and then we create a magics class. I use a line cell magic here. We take the line and use the shell lexer to split it into arguments. That's why it literally looks just like what you would type at the command line. And then we add this, if the cell is none, not none, we add that to the args, and then we just call the main function from the command line interface, and that's it. When you import this lab, we check if there's an IPython. That means you're in the Jupyter notebook, and if there is, then we register these magics, and if not, then you're at the command line, and we're in a Python script, and it doesn't matter, so we don't need to do that. So it's remarkably simple to get this capability. A couple of things had to change since the previous videos that should be mostly invisible. When we use the magics, then you have to be careful about where you get the config in the database, because you might change the directories, and so I had to modify the init files and created the utils file here, so that each of the CLI commands should get the config and database on demand from the right place. So if you're changing paths and changing into different litdbs, everything really should just work. If it doesn't, it's a bug, and you should definitely report that on GitHub issues. Alright, 24 more. So what litdb follow does is goes to OpenAlex and gets all of the entries associated with this work ID, and those are mostly articles, but it includes some conference proceedings and some other things. Alright, so now we're following me. Now if I look at my database, it says we have 224 sources. It's still quite small. Now we can do some vector searches. This is the line magic where we have a single percent. Maybe here I can say -n2, and this is the cell magic, so this will only give me two matches. And we can get a citation for one of them, so if you want to, you can copy and paste this. It's a little annoying, it has these HTML tags. Probably that's fixable. We could have it display this, but right now that logic is sort of tied with the rich printer. We can get bibtec entries, so you can copy this into a bibtec file. We can do full text search either as line magic or as cells down here. GPT also works. It's not the fastest thing in the world, but now I'm running this on an M4 Pro, and so it's typically like 18 to 30 seconds, but you can see that the embedding is order 1 second, next to nothing to find the to do the RAG, and then here it tells you what it's learned based on the kinds of things that are in the references that it found, and it gives you these references down here. If you want to find similar articles, that also works. Similar is done by virtue of vector similarity, so this is going to find similar articles that are already in your database. That might be useful. Suggesting reviewers, here it's going to prompt me if I want to look for anything better. I'm going to say no, because what that does is it goes out and gets all of the references and citations of each article. That can be time consuming, but here we have 5 suggestions. Unfortunately, that none of these are actually good reviewers for any of my work, because these are all my students, so we would probably need to let's do -n. Actually, this is, maybe it's not the best example, because there are only my papers in the database right now. This works best when you have lots of other people's papers. maybe if I say search for better matches, it would download all of these articles and try that. You know, let's just try that. Yes. So now we're going to have to go through 117 and then 10. Maybe we can even just try running this. So unpaywall, oh no, it's going to wait for that one to finish. This doesn't run async, so it's blocking. Maybe I'll just stop this. Let's see if I can do that. And we'll try again. Say no. That still finds us my work as the closest. Unpaywall is a service that tries to find PDFs, and these are not clickable links. They probably should be, but you can get to a PDF that way. This is another place where I have to kind of find the right balance between am I at the terminal or am I in Jupyter Lab. You can do a search. This does not add anything to the database. It just finds articles that OpenAlex uses to search this. Kind of seems like that's not right, but what happens if I put this in quotes? Well, it's prompting me down here. Let's say no. Yes, I'm surprised that single atom alloys pops up things like this. That seems dodgy. Let's say no. You may want to do a web search. This will launch all of these different sites: bioRxiv, chemarchive, archive. I guess this is going to be, let's see. PubMed somehow wants me to log in. Google Scholar, all of those sound good, even just regular Google. And of course we have OpenAlex here with single atom alloys. This seems like much better. So I'm pretty skeptical about this OpenAlex here thing, that it's not doing the right thing. Let me just check. That's default search. Maybe that's different than full text. This I'll have to fine tune that one. I see, I'm not using it right. We should do -F. Nope, that's not it either. Something's off here. I'll look into it. I showed you this one, and then lastly, this one is nice. I guess I need to say no. Here we can get a COA. This is the NSF form. This will get the table 4 from this orc ID, and if you download this, you can see here it opened, and these are all of my collaborators and when they were last active and papers that we've written. You still have to go through. There's often duplicates like these two that end up being different OpenAlex IDs. You have to eliminate your own name, and you may want to update some of these. There's some more duplicates. You can see there's a period versus not. All those kinds of things lead to duplicates. They're not easy to detect, so you have to do it manually. But it's a lot easier than curating this list manually. Okay, so that's all. I think the only thing that doesn't seem to be working quite right is this OpenAlex command, and I will fix that after this video is over, and then it will work like it's supposed to. All right, that's it. Now you can use litdb in Jupyter Lab, so you may find that more convenient than the terminal or using it in Emacs. That's all. See you later.